Hello students, welcome to Akshara IIT Foundation. So myself Shiv Shankar, I am going to teach the physics concepts. So today we will continue last concept we have discussed about the applications of dimensional analysis and we have done the practice sheet 5. We have completed the practice sheet 5. Today we are going to see the synopsis 6. In synopsis 5 we have completed practice sheet 5 and exercise mains level 1 and level 2 we have completed. So here my task problems are there that you can solve it and you can raise the questions, you can raise the doubts, okay, that will be discussed later. So now today we are going to see the synopsis 6. This is about it is also applications of the dimensional analysis. There are 3 applications are there in that it is a one. So that is the conversion of units from one system of units to other system of unit. So they may give the SI system of unit into, they may give the SI system and they may ask to find out CJ system, and they may give the CJ system of units and they may ask to find out to convert into its SI system of units. Okay, that we are going to see. So to convert from one system of unit into other system of unit, we have to follow 2 rules. First, given any system of unit, we have to convert it into the SI system. Then we can convert that into the required system of unit, what they asked. Okay, to that system we can find out there. We can convert. Okay, now we'll see there. Conversion of units. Conversion of units. Conversion of units. So by using this dimensional analysis, we can convert one system of unit into other system of unit. So to convert that, so we have to follow certain rules. So first rule is convert given units into SI system. So first given system of units has to be converted into SI system. Then we have to convert that into the required system. We have to convert a given system of unit into the SI system. Then from there, so what is the required system of units they are asking there, to that we can convert there. Okay. So then second one is convert into derived system of unit. Derived system. So derived system means, so to which system of units they want to convert, to that system we can find out there. So it is better to convert first SI system. From there we can convert from the SI system. It is better we can convert easily to the required system of unit. Okay, these two rules we have to follow there. So here we'll see the example. Suppose, see the example. Suppose here 10 centimeters is equals to how many millimeters? How many millimeters? Okay, how many millimeters? So here we'll convert this into the SI system first. Okay, SI system. So here this centimeters is in a CGS system. So we can convert this into centimeters. So 10 centimeters is equals to 10 by 100 meters. This is a SI system. Okay. So now this and this will be cancelled, and here we will get there 0.1 meters. So from how can you convert here? 1 meter is equals to 100 centimeters. Then 1 centimeter is equals to 1 by 100 meters. 1 by 100 meters. So we can convert. We have converted this into this one. So we know that 1 meter is equals to, we can write here 1000 centimeters. 1000 millimeters. 1000 millimeters. Okay, here 1 centimeter, we know that 10 millimeters. Since 1 centimeter is equals to 10 millimeters, so we can convert easily now. Okay, so now here in place of 1 meter, here we can write now 0.1 into, here 1 meter, how many millimeters? 1000 millimeters. 1000 millimeters. Okay, so here we will get here this one. So 10, so 0.1 is 1 by 10 into 1000. This and this will be cancelled there. Here millimeters will get there. Therefore 10 centimeters is equal to, will get here 100 millimeters. 100 millimeters. Okay, or else so 10 centimeters, they are asking millimeters, no? Simply by using this 1 centimeter is equals to 10 millimeters, no? Here 10 centimeters is equals to 10 into 1 centimeter, how many millimeters? 10 millimeters. So directly we can write here. So 10 centimeters into is equals to 100 millimeters. Like this also we can do that. Which one is easy? We can follow that one, no problem. Okay. We'll see now one more example. We'll see one more example here. Yes, now one more example. In one example we'll see there. Second example. So second example we can write there. Yes. So here we can write there. So 1 Newton is equals to how many dynes? How many dynes? 1 Newton is equals to how many dynes? Okay. So 1 Newton is nothing but the unit is Newton is nothing but kg meter per second square. Kg meter per second square. So now this kg has to be kg. In dynes means this is the CGS unit of force, and this is a SI unit of force. SI unit of force. So Newton is nothing but SI unit of force, and dyne is nothing but CGS unit of force. Okay. So now kg, 1 kg we know that 1000 grams. 1000 grams into 1 meter 100 centimeters. So seconds is as it is seconds only, since here it is from 1 kg. 1 kg is equals to 1000 grams, and 1 meter is equals to 100 centimeters. In place of kg and in place of meter, CGS units we have written there. So now it will be converts into the CGS unit. So this is 1000 into here 100. So we'll get 1 lakh. Okay, 1 lakh will get here gram centimeter per second square. So this we can write here 10 to the power of 5 zeros, 10 to the power of 5 we can write here. This is said to be the dyne. Since dyne is nothing but dyne is equals to gram centimeter per second square. Okay. So therefore we can write here 1 Newton. 1 Newton is equals to 1 Newton is equals to 10 to the power of 5 dynes. 10 to the power of 5 dynes. This we can find out there. Even we can write from here. From that we can write so 1 dyne is equals to how many newtons? Like that also the mass there. Simply we have to send this 10 to the power of 5 to the left side. It will become divide here. So 1 dyne is equals to, here it will become dyne is equals to 1 dyne is equals to 1 by 10 to the power of 5 newtons. So 10 to the power of 5, 1 by 10 to the power of 5 newtons we can, So if you want to write in the numerator, we will get like this, 10 to the power, this is equals to 10 to the power of minus 5 Newton. Since we know that a power minus n is nothing but 1 by a power n. So if it is there this like this, 1 by a power n, okay, 1 by a power n, so 1 by 10 to the power of 5, so that can be written as a to the power of minus n, we can add there. So here we have written that 10 to the power of minus 5, okay, like that we can convert there. So even we can convert that into the SI unit of mass to the Phsyics unit of mass and SI unit of time, okay, and we can convert any system of unit into the other system of unit easily by using this dimensional analysis. Now practice sheet, we'll see now practice sheet 6, page number 41, page number 41, practice sheet 6, okay. It's completed now. Sixth practice sheet. Practice sheet. Practice sheet. Okay. So first question is here. Concept based questions is given. Among the following, the smallest unit of time. Among the following, the smallest unit of time. First option is given here, millisecond, and second option is given microsecond, third option is given nanosecond, and fourth one is shake. Okay. So first option is given here. First question, which of the following this is correct? So first option is given here millisecond, and second option is given microsecond, and third option is given nanosecond, and fourth option is given shake. Okay. So from these three, what will be the smallest unit of time? Smallest unit of time. These are all the unit of time. So we can convert that. So from that all the units, which one is the smallest one? They are asking. So here milli means, we can write here milli is nothing but 10 to the power of minus 3 seconds, and this one is 10 to the power of minus 6 seconds, and this is a nano means 10 to the power of minus 9 seconds there. Okay. So we can write here from that all. So which one is we can write here? Okay. So this is a millisecond, and this shake is nothing but is more than greater than this all. So greater than, we can write here it is 0. These are all the less than 0. So these all units we can write here, they are the less than 0. These are all the less than 0 values, and this shake is nothing but is greater than 0. So from this millisecond, milli means 1 by 10 to the power of minus 3 means, from this formula we can write now here, from this formula, a power minus n is nothing but 1 by a power n we can write. So here from this 10 to the power of minus 3, here we can write that 10 to the power of 1 by 10 to the power of 3 means here 1 by 1000 seconds. Like that it is 1 by 6 times. So 1 by this one. So compared to this one is a lesser one, and this is a greater one, and this is a greater one, and this one is the lesser one, and this one is very lesser one, this is a greater one. Okay. So from this we can write here this fourth option is greater. Okay, then first option. So first option is greater. Then 10 to the power 6. This is nothing but here to second option, and then third option is what there? Third option. So now here this is a increase in order. This is a greater. Okay, this is a descending order. This is a greater one and descending order. So smallest one is the third option. No? So this is the answer we can write here. Smallest one will be the nanoseconds. Nanoseconds. Okay, that is the first one. Next one you see there. Among the following, the odd one is. Among the following, the odd one. So they given here first option pound, quintal, ton, angstrom. Okay, pound, quintal, ton, angstrom. So which one is the odd one? We have to find out there. Which is the odd one? Understood now this one? Second one. So there are four options are given. From that, which one is the odd one? We should find out. So here second one. Second one is given here, two option, pound, and second one is given here, quintal, and third option is given, ton, and fourth one is given angstrom. Fourth one is given angstrom. Okay. So pound is nothing but these three, pound and quintal, ton. These are all related to the mass. Means these are all the pound, ton. These are the measurements of mass, pound and quintal, ton. They are the relatives related to mass, and this angstrom is related to length. So now we can say these three are the related to mass and this is related to the length. So the odd one is here, angstrom we can say that. Okay. So now the answer is, the correct answer, option 4 is the correct answer. This is the odd one. So from this all the option, odd. So odd one is what? Different one. Different one is where to find out there. Next question. Among the following, which is not a unit of time? Among the following is not the unit of time. So here options are given. This is completed now. Third one. Among the following, which is not a unit of time? Not a unit of time. So from the following these all the options. So first one is given here, leap year, and second one is lunar month, third one is light year, and all of the above. Fourth one is given all of the above. Okay, fourth one is given all of the above. Okay, so now from that, so this is a leap year. It is related to time. Lunar month related to time. light year. Light year is the light year is nothing but it is related to the distance. Light year is nothing but related to the distance. The distance traveled by the light in a year is called the light year. So the distance. This is about the these two are the related to time. These are related to time, and this one is related to distance. Distance. So now not unit of time they asked there. So correct answer is this one. Okay. So now the answer is option 3 is correct one. Option 3 is correct one. Next question. 100 centimeter is equals to 100 centimeter is equals to, okay. Next, fourth question. Here the fourth question is given. 100 centimeters is equals to dash. Here the options are given. 1 meter. Second option is given. Second option is given here 10 meters. 10 meters. And third option is given 1000 meters. 1000 nanometers. 1000 nanometers. And fourth option is given here. Fourth option is given here 100 meters. 100 meters. 100 meters. So here it is given there 1 meter, 100 centimeters is equals to 1 meter, 10 meter, 1000 nanometer, okay, and here this is a 100 meters. So we know that already just now we have seen 1 meter. So 1 meter is equals to here 100 centimeters. Then 100 centimeters is equals to 1 meter. So here we can add this one, 1 meter. So this is not 10 meters is not correct. This is not, and this is not. So therefore the answer is option 1 is a right one. Okay. Next, fifth question. Fifth question is given here. 15 millimeter square is equals to. So fifth one, 15 millimeter square is equal to. Here options are given. First one is 15 into 10 to the power of minus 2 centimeter square. 15 into 10 to the power of minus 2 centimeter square. And second option 15 into 10 to the power of minus 6. 15 into 10 to the power of minus 6 meter square. And 15 into 10 to the power of 12. Third option is given. 15 into 10 to the power of minus 12 kilometer square. So fourth one, all of the above. So all of the above. Yes. So that is the given here. See now here solution we can add there 15 millimeter square. Okay. So here 15 into we can add here 1 millimeter. So 0.1 centimeter. 0.1 centimeter whole square. Since 1 millimeter is equals to 0.1 centimeter. 0.1 centimeter. If you substitute here, in place of 1 millimeter, if you substitute there, 0.1 and square is there, we should do the square there. So it can be written as 15 into this, we can write here 1 by 10, no? 1 by 10 whole square, 1 by 10 whole square, centimeter square we can write. So this can be written as 10 into 15 into, so 1 by 10 square we can write centimeter square from the above formula, this one here 15 into 10 to the power of minus 2 centimeter square we can write that. Okay, so this is from a power minus n is equals to 1 by a power n, we can write like this. By using this one we can write here numerator to the numerator. So here this is in centimeter square. Now meter square, we'll see in the meter square. So up to here for first option, no? So this will convert into the meter square now, 10 to the power of minus 2. 1 meter is nothing but 1 by 100 1 by 100 meters. 1 by 100 meters whole square. Since we know that 1 meter is equals to 100 centimeters, from 1 centimeter is nothing but 1 by 100 meters whole square. So here we will get there 15 into 10 to the power of minus 2, and here 100 whole square means 10 to the power of minus 4 will come there, 10 to the power of minus 4. So here 10 to the power of 4 will come there, meter square will be there, and if you send this to the numerator, will come here 15 into 10 to the power of minus 2 and into 10 to the power of minus 4. So we will get here 15 into 10 to the power of minus 6 meter square. Okay. So now see the first option. In the first option, this is also correct. And in the second option, now 15 into 10 to the power of minus 6 meters. This is also correct. And we'll see, we'll convert it to the kilometers. We'll convert it to the kilometers there. I'll write here. So this will be the third option. Third option. So this is we got in meter square, it is 15 now into 10 to the power of minus 6 meter square we got now. So 1 kilometer is equals to 1000 meters. 1000 meters. 1000 meters. 1000 meters now. 1000 meters. So from this, now in place of here, so 1 meter is equals to 1 by 1000 we can write now. So here 15 into 10 to the power of minus 6. Here 1 by 1000, 1 by 1000 meter whole square, 1 by 1000 kilometer whole square we can write. So this is a 15 into 10 to the power of minus 6 and 1 by, this is the 10 to the power of minus 6 now, here we will get the 10 to the power of 3 and here, so 10 to the power of 1 by 1000 into 1 by 1000, 10 to the power of 1 by 1000 whole square is nothing but 1 by 1000 into 1 by 1000 we can write there here. 10 to the power of 6 will come now here. This is a kilometer square. If you send it up, so it will be 15 into 10 to the power of minus 6 and into 10 to the power of minus 6. So kilometers square. So therefore, we will get here 15 into 10 to the power of minus 12 kilometer square. So here also we got same answer, no? So this is also correct. So now these are all correct means all of the above is a correct answer. So therefore answer option 4 is the correct one. Complete na? Sixth one now. Sixth one we'll see. Is it over? Here the question is given, x kilometer per hour, x meter per second is equals to dash is equals to y is equals to y kilometer per hour, kilometer per hour. Okay. So then x by y, x by y is x by y is the question mark. Okay. So here they are asking x by y, no? So means the given here given is x meter per second is equals to y kilometer per hour. We are asking y by x. So from the, if you send this y this side, it will become 1 kilometer per hour is equals to x by y meter per second, we can write now, meter per second. And we know that 1 kilometer per hour. So see here, we will see 1 kilometer per hour. So 1 kilometer means how many meters? 1000 meters. And per 1 kilometer 1000 meters per means divided by hour. 1 hour, how many seconds? 1 hour 60 minutes. 1 hour 60 minutes into 60 seconds. So we will get seconds. So since 1 kilometer is equals to 1000 meters and 1 hour is equals to 60 minutes. 60 minutes, and again here 1 minute is 60 seconds. 60 seconds. Okay. So now from this we can write here 1000 meters divided by this is 3600 seconds divided by seconds, we can write down 2 zeros and here will be cancelled there. So 2 5s are 2 18s are. So therefore we will get there 5 by 18 meter per second. Okay. So now we got here 1 kilometer per hour, 1 kilometer per hour. So now from this 1 kilometer per hour is x by y. So now compare these two. If we compare these two, we will get here x by y. X by y is equals to 5 by 18. 5 by 18. X by 18. X by y is equals to 5 by 18. So here the option, correct answer is option first one. Option first one is correct. So will there eighth question. It has given there. Eighth question is given here. SI unit of force. SI unit of force. The ratio of SI unit of force to the CGS unit of force. Okay, CGS unit of force. So we know that. So this is a SI unit of force is a Newton divided by this will be the dyne. So we know that 1 dyne is equal to 10 to the power of 5. 1 Newton is equal to 10 to the power of 5 dynes divided by dyne. So this and this will be cancelled there. So now from here 1 Newton by dyne is equals to, we will get here 10 to the power of 5. Therefore we can write here the ratio of Newton is to dyne is equals to 10 to the power of 5 is to 1 will get. So this is the answer. So from that we can say it is the correct answer is option 3. Option 3. Now 10th one. So 9th one, no? Yes. Now 9th one we will see there. Is it clear? So ninth one is given here. One kg per meter cube. 1 kg per meter cube is equals to dash milligram per centimeter cube. Milligram per centimeter cube. So here we see the solution. So 1 kg per meter cube. 1 kg per meter cube. 1 kg we know that it is the 1000 grams divided by 1 meter, here 100 centimeter, and whole cube is there, we can write here cube. Since 1 kg is equals to 1000 grams, and here 1 meter is equals to 100 centimeters. So we have written here, okay. So now here we'll get 1000 grams divided by, here we'll get there, so 10 to the power of 2, 10 to the power of 6. This we can write here 100 means 10 to the power of 2 whole cube centimeter cube we can write here. Okay. So now this can be written as here 10 to the power of 3 now, and here divided by 10 to the power of minus 6 gram per centimeter cube. Gram per centimeter cube. Sorry, it is plus only 10 to the power of 6. If you send it numerator, so from this we will get here 10 to the power of 3 into 10 to the power of minus 6 gram per centimeter cube. And here we can write there 10 to the power of minus 3 gram per centimeter cube. So now therefore here we can write now 1 kg. 1 kg per meter cube is equals to, this we can write here milli 10 to the power of minus 3 is a milligram per cube, centimeter cube we can write. So here we can write here 1. Since 10 to the power of minus 3 can be written as m, symbol of the milli, symbol of the milli is small m. So in place of 10 to the power of minus 3 we can write here 1. So here we will get how much there? 1. So here the answer will come there 1. So therefore now answer, so this is answer now here. That is answer. So correct answer is option is 2. Option 2 is correct one. Okay. Now 11th one. 10th one. 10th one already we have done there. 1 Newton is equal to how many times? So 10th one is 5, first option we can write there. 10th one is the first option. Direct, there are many times we have done there. And now 1 joule is equal to erg, dash, how many ergs? So here we can write there 10th one. 10th one now direct answer, that is the 1 Newton is equals to 10 to the power of 5 dyne. 10 to the power of 5 dyne. So answer is, this one will become, this is the answer. We have completed this already. Okay, now 11th one we will do there. Eleventh one. 11th question. Here they are asking 1 joule is equals to how many? So 1 joule is equals to dash erg. Okay. So here joule is nothing but 1 joule is equals to Newton meter. So Newton meter is nothing but Newton is about kg meter per second square, and here meter. So we will get here kg meter square per second square. Kg meter square per second square. We know that kg, 1 kg is nothing but here 1000 grams, and 1 meter is nothing but here 100 centimeter whole square 10 to the power minus 2. So here 1000 will be there, 1000 into here 10 to the power 2. Here 10 to the power of means 1000. 100 whole square means 1000 into 100 into 100 will come, you know. So here gram centimeter square second square will come there. So how many zeros are there here? 3 zeros and 4 zeros. So 10 to the power of 7. 10 to the power of 7 gram centimeter square. Gram centimeter square per second square. So therefore 1 joule is equals to 10 to the power of 7 gram centimeter square 10 to the power of minus 2. So here gram centimeter square 10 to the power of minus 2 is nothing but erg. That is the erg. So therefore here we can write 1 joule is equals to 10 to the power of 7 erg. So now that is the answer. The correct answer is this one. Correct answer is. So now here the answer answer is option 3. Option 3 is correct one. Okay. So next exercise is there, that will continue in the next class. So in the next class we are going to complete this exercise, and then next chapter we are going to start, that is the measuring instruments. It is about the screw gauge. So we are going to learn about the screw gauge in the next after this in the next class almost we will complete exercise. Okay. Then after that in the next class we are going to see here measuring instrument, that is the screw gauge. Okay, thank you children. Thank you all.